Last class, we have studied how to locate irrational numbers like root 2, root 5, etc. on the number line. Today, we will be studying how to locate numbers which is represented in decimal expanded form, which is approximated to some 3 or 4 digits in the number line. For that, we will be using the method of successive magnification. We will be using the method of successive magnification. So we will be locating the number 3.765 on the number line. First, we will be drawing the number line like this. See, we have to map 3.765. See, take this as the origin or 0. Then 1 centimeter away from origin, we located 1, then 2, then 3, like that we have marked the units on the number line. So to the left side we have -1, -2, -3, etc. Now we can see that 3.765 is a number which falls in the interval 3 to 4. 3.765 falls in the interval 3 to 4. So we will be zooming the interval between 3 to 4. We will be zooming the interval between 3 to 4. See, here see 3 is mapped to this point and 4 is mapped to this point. And the interval between 3 and 4 is divided into 10 equal parts. See, this is 3.1, 3.2, like that. See, 3.765 lies in the interval 3.7 to 3.8. And 3.765 falls in this interval 3.7 to 3.8. Then again we will be magnifying the interval from 3.7 to 3.8. Take this as the point 3.7 and this as the point 3.8, and we will be dividing the interval between 3.7 to 3.8 into 10 equal parts, and we will be marking 3.71, 3.72, like 73, 3.74, like that. So we can see that 3.765 lies in the interval 3.76 to 3.77. 3.765 lies in the interval, it falls in the interval 3.76 to 3.77. We can see that it is exactly the midpoint of 3.76 and 3.77. Then again we will be zooming the interval from 3.76 to 3.77. Take this as the point 3.77 and this as 3.761, then 3.762, 3.763, 3.764 and 3.765. Now we have got the exact location of the number 3.765, and we will be marking the remaining units also, like 3.766, 3.767, etc. See, now we have located the exact location of the number 3.765. This is called the method of successive magnification. I think now you have understood what is meant by the method of successive magnification. Now we will be studying some concepts that we have studied in the previous class. This is needed for the next module 1.5. See, 2 plus 2 plus 2 is equal to 3 into 2. 2 is added 3 times. 2 is added 3 times, that is 3 into 2. It is also equal to 2 into 3 because multiplication is commutative. We can see that multiplication is commutative in the sense A into B is equal to B into A. The order in which the operand, this is 3 is an operand, 2 is an operand. This is the operator. Operator is multiplication. So the order in which the the order in which the operands occur is immaterial. So 3 into 2 is equal to 2 into 3. So multiplication is commutative. So 2 plus 2 plus 2, 2 is added 3 times is equal to 3 into 2. In general, if a is added n, if n times a is added, or when n a's are added together, we get n times a, that is equal to na. N a's are added together, we get n into a, na. This is the meaning of multiplication. Adding n a's is equal to n into a. 2 into 2 into 2 is denoted by 2 to the power 3 or 2 raised to 3. Multiplying 2 3 times, or 3 2's are multiplied together 3 times. 3 2's are multiplied together, we get 2 raised to 3. 3 2's are multiplied together, we get 2 raised to 3. If n a's are multiplied together, see, n a's are multiplied together, we get a raised to n. So a raised to n means a into a into a up to n times. Now we will see 2 raised to 3 into 2 raised to 3 times 2 squared, or 2 raised to 3 into 2 raised to 2. 2 raised to 3 is 2 into 2 into 2, 3 times. Then multiplication symbol is here. Then 2 squared is 2 into 2. This is 2 is multiplied 5 times. Yeah, 5 2's are multiplied together, we get 2 raised to 5. How we get this? We got this by adding the exponents 3 plus 2. That is 2 raised to 3 into 2 raised to 2 is equal to 2 raised to 3 plus 2. In general, a raised to m multiplied by a raised to n is equal to a raised to m plus n. A raised to m times a raised to n is equal to a raised to m plus n. The exponents are added to multiply a raised to m into a raised to n. See, 2 raised to 3, the whole squared, the 2 raised to 3, the whole squared. Take 2 raised to 3 as some x, then it is x into x. Instead of x, write 2 raised to 3. Now 2 raised to 3 squared is equal to 2 raised to 3 times 2 raised to 3. 2 raised to 3 multiplied by 2 raised to 3. That is equal to 2 raised to 3 plus 3. A raised to m into a raised to n. Here m is equal to 3, n is also equal to 3. A is 2. A raised to m plus n. We get 2 raised to 3 plus 3. That is equal to 2 to the power 2 into 3. 2 to the power 2 times 3. So a raised to 3, the whole raised to 2 is equal to a raised to 2 into 3. These two exponents are multiplied together. Similarly, 5 squared, the whole cube, 5 raised to 2, the whole raised to 3. This is equal to, take 5 squared as some y, y into y into y. See, 5 squared times 5 squared times 5 squared. This is a raised to m into a raised to n into a raised to some p. So the exponents are added together. 5 raised to 2 plus 2 plus 2. This is equal to 5 raised to 2 times 3. 5 raised to 2 times 3. 5 raised to 2 into 3. See, we can see the exponents are multiplied together. Similarly, a raised to m, the whole raised to n is equal to a raised to m into a raised to m into a raised to m n times. A raised to m occur n times. This is equal to a raised to m plus a raised to m, a raised to m plus m plus m. How many times m occur? N times. M is added n times. We get m into n. We get m times n. A raised to mn. We get a raised to mn, a raised to m into n. So a raised to m the whole raised to n is equal to a raised to m n. See, a to the power minus n or a raised to minus n is defined as 1 by a raised to n. A raised to the power minus n is equal to 1 by a to the power n. For example, 2 raised to minus 3. 2 raised to minus 3, 2 to the power minus 3 is equal to 1 by 2 to the power 3. This is the definition of having negative in the exponent part. A raised to minus n is equal to 1 by a raised to n. So we know that square root of 2 is equal to 2 to the power 1 over 2. Square root of 2 is 2 to the power 1 over 2. See, square root of 2 the whole squared is equal to square root of 2 is 2 to the power 1 over 2 the whole squared. See, this is a raised to m. Here m is equal to 1 by 2 and n is equal to 2. A raised to m the whole raised to n is equal to a raised to e. A raised to m the whole raised to n is equal to a raised to m into n. A raised to m into n. A raised to m the whole raised to n is equal to a raised to m into n. This 2 and 2 will get cancelled and we get 1. This is 2 raised to 1 is equal to 2. So square root of 2 the whole squared, that is square root of 2 into square root of 2 is equal to 2. Similarly, cubic root of 8 is equal to 8 to the power 1 over 3. Cubic root of 8 is 8 to the power 1 over 3. But we know 8 is equal to 2 to the power 3. 2 to the power 3 the whole raised to 1 over 3. This is a raised to m the whole raised to n. Here m is equal to 3, n is equal to 1 over 3. So the exponents are multiplied together. 2 to the power 3 times 1 over 3. This 3 and 3 get cancelled and we get 2. The result is 2. See, nth root of a. Nth root of a the whole raised to m. Nth root of a means what? Nth root of a is a number x such that when x is multiplied n times or x raised to n is equal to a, that x will be called nth root of a. Nth root of a is a number x such that x raised to n is equal to a. Then nth root of a the whole raised to m is equal to, we know that nth root of a is denoted by a to the power 1 over n. A to the power 1 over n the whole raised to m. Now this is a raised to m into n or a raised to x into y. Take this as x and this as y. A raised to x the whole raised to y is equal to a raised to xy. This, so we get a raised to m by n. See, this is a times inside bracket a plus b is equal to na plus nb. This property is called multiplication is distributive over addition. This property is called multiplication is distributive over addition. Precisely, this is multiplication is left distributive over addition. This the term n occur on the left side. Multiplication is left distributive over addition. Multiplication is left distributive and right distributive over addition because multiplication is commutative. So we don't need to specify whether it is left distributive or right distributive because multiplication is commutative. See, multiplication is commutative over addition. N times inside bracket a plus b. N times a plus b. N times inside the bracket a plus b is equal to n a plus nb. 2 times 3 plus 4. Inside the bracket we have 3 plus 4 is equal to 2 into 3 plus 2 into 4. This n a plus nb. Here n is equal to 2, a is equal to 3 and b is equal to 4. This is multiplication is distributive or addition. See, a plus b times c plus d. A plus b inside bracket and c plus d inside bracket. A plus b times c plus d. Take c plus d as some y. Take c plus d as some y. Then we get ay plus by. Instead of y, write c plus d. Take c plus d as some y. Then we get ay plus by. See, ay plus by. Instead of y, write c plus d. Now we get a times c plus d plus b times c plus d. C plus d inside bracket. Then we will apply the property, namely this multiplication is left distributive or addition. We get a times c plus a times d. A goes inside, and b times c plus d is bc plus bd. So we get ac plus ad plus bc plus bd. See, multiplication is actually done like this: ac plus ad, ac plus ad plus bc plus bd. So ac plus ad plus bc plus bd. Now this is a special case of a plus b into c plus d. See, instead of c plus d we have a plus b again. A plus b times a plus b. This is then in the same way we have to multiply. We get a into a squared, a into b, ab, then b into a, ba, b into b, b squared. Then we get a squared plus ab plus ba and ab are same. So we will be writing ba as ab. So a squared plus ab plus b squared. So the net result is a squared plus 2ab plus b squared. We have to study this formula, a plus b whole squared is equal to a squared plus 2ab plus b squared. Similarly, a minus b the whole squared is equal to a squared minus 2ab plus b squared. Now consider a plus b times a minus b. A plus b inside bracket and a minus b inside bracket. A plus b times a minus b. In the same way we multiply a times a minus b plus b times a minus b. This is a squared, the a into a squared minus ab plus ba minus b squared. We know that ab and ba are same. So the next step will be writing ba as ab. So this ab and ab get cancelled. We get a squared minus b squared. So a squared minus b squared. A plus b into a minus b is equal to a squared minus b squared. So a squared minus b squared is equal to a plus b into a minus b. This is a very important formula. A squared minus b squared is equal to a plus b into a minus b. For example, 3 squared minus 2 squared is equal to 3 plus 2. Instead of a we have 3 and instead of b we have 2. 3 plus 2 into 3 minus 2. And we have completed this lesson here. Tomorrow and then next we will be studying the module 1.5. Thank you.